Good day, ladies and gentlemen. This is Sarel van Glenn, aka Mr. VG, and I am excited to be on this journey with you. I'm excited to have you here, and it's such a privilege for me to be able to serve you today. Today, we are going to look at one of the most amazing and fantastic, wonderful things that you will ever come across in mathematics, because it's inequalities with fractions. In other words, quadratic inequalities that have got fractions either in the denominator or in the numerator, but mostly we are going to look at ones that have in both. And this is a bit of a toughie. This is a bit of a difficult thing. So I'm encouraging you. Keep up with me. Hit the pause button if there's something that you are struggling with, there's something that you are maybe not understanding. Rewind, rewatch the video. But remember to buckle up and have fun with me. If there is anything that you are struggling with, please ask, a teacher, ask a tutor, ask a friend. Let them help you make sense of this wonderful, wonderful topic of inequalities with fractions. The first one is going to require a bit of mind-boggling. Some of those weird mathematics. It's going to require quite a bit of that. The second one is for the guys who don't like the weird mathematical mind-boggling. They like more to go. They just learn this and do this. It's go for those marks instead of maybe thinking outside of the box. So buckle up. Have a wonderful time with me today. Let's have a look at inequalities with fractions. So when I talk about inequality with fractions, what I'm specifically going to talk about is the interesting little thing that happens when I am working with times or divide of expressions. For instance, that plus times a plus, which you see on the screen now. If I multiply them, the answer is a positive. But what if I say a plus divided by a plus? It's still a positive. What about a plus times a minus? Well, that is a negative. And a plus divided by a negative? Well, that's also a negative. Now, this is a little bit of an interesting, head scratch moment, because in inequalities, especially when there's a zero on the one side, we are going to constantly look at this thing of, multiplication versus division. Hold on tight. Let's look at an example. Let's say I've got x over x plus 1 larger or equal to 0. In other words, x divided by x plus 1 needs to be a positive answer. So let's just quickly look at when is x divided by x plus 1 a positive answer. Well, that's going to be when I've got a plus divided by a plus, but that could just as well change into a multiply. Or I could have a minus divided by a minus, which also changes into a plus, and I can just as well replace the divide with a times. So in other words, in essence, whether I say a plus times a plus or a plus divided by a plus, the answer is still positive. Same goes with the negative. So what am I telling you? And this is now a really weird little bit of maths, head scratching that you need to do. I could just as well actually ask the question of x times by x plus 1 greater or equal to 0. I want you to think about what I just did. Remember, I want something divided by something being a positive. But that's exactly the same as if I say that something times by the other something is a positive. So in other words, it actually doesn't matter whether I times or divide, because I'm purely looking at whether the expression is a positive or a negative. If I look at what's written down on the screen now, well, this we actually did in the previous example or the previous video. The previous video, we would just go and draw this. But there is one difference. X plus 1 may not be 0. Why is that? If you haven't figured it out yet, well, that's simple, because I'm not allowed to divide by 0. So my denominator is not allowed to be 0. And that's the big difference between divide and times. With divide, there is that little bit of a restriction that your denominator may not be 0. That isn't there with times. So let's continue with this sum as if it now is a times instead of a divide. And let's draw our sketch with our roots being 0 and negative 1. And it's a smiling parabola that needs to be larger or equal to 0. So we cross out the negatives. That leaves me with those two sets of answers. X, which could be from negative infinity to negative 1. But now be careful. Negative infinity is always a round bracket, and it's not allowed to be negative 1, so we can't have a square bracket. Even though there's an equal in the sum, an equal 0, we're not allowed to have negative 1. Or from 0 to infinity, now it can touch 0 and it never touches infinity. This is a bit of a mind boggler, and I'm going to say that word a few times, yes, because it messes with your mind. Changing a divide into a time simply because I'm just looking at positives and negatives, not actual values. Let's try another example. What if I now give you x over x plus 3 greater than 2? There's quite a few of my students that are tempted to do the following. Times by x plus 3 on both sides. Why would I give you 0 if you do this? Why? The answer is quite simple. We do not know whether x plus 3 is actually a positive or a negative. In other words, if it's a positive, the inequality sign stays the same. But if it is a negative, well, then the inequality sign has to swap around. So, whoa. I am not allowed to do this. I'm not allowed to times by x plus 3. So what must I do? Well, I want 0 on the right-hand side. So I'm going to bring over that 2, and it becomes a negative 2. Now I need to put on the LCD, which is x plus 3. So to get the 2 over x plus 3, I need to times top and bottom by x plus 3, and that leads me to the following expression. I'm going to now simplify this expression. I'm multiplying out. And that leads me at the top to negative x minus 6 over x plus 3 greater than 0. Now, important thing, and I said in the previous video, I'll do more explanations on this. Please, you need to have your coefficient of your x's, so in other words, that one and that one, to both be positives. The reason for this is so that we make sure our parabola ends up, or our cubic graph ends up. That's very important. So we have to manipulate this thing a little bit. So I'm going to times straight through by negative 1 over 1 on the left. So let's not, because there's always one or two students who's asking me. But so where must the negative 1 times into? It actually doesn't matter. But I'm going to choose that it times into the top, because I want the top one to be negative, or not to be negative, to change into a positive. So I'm going to times that negative 1 into the top and the plus 1 at the bottom. So this leads me to go x plus 6 over x plus 3. But now my inequality sign swaps around because I multiplied by a negative straight through. Now I'm going to go, instead of dividing, I'm going to times. And this, again, is a very straightforward parabola with one restriction. X plus 3 may not be naught, so x may not be negative 3. In this parabola now, I've got my two roots, one at negative 6 and one at negative 3. So if I want smaller than 0, I close off the bigger than 0. And this leads me towards saying that is my final place. So in other words, x is between negative 6 and 3. And neither of them are included because I don't say equal to 0. Round bracket. Woo! Easy and simple and straightforward. No, sir. No, this is not easy. So in a nutshell, what I did in this sum was always the first thing, which is get that 0 on the one side. Secondly, then I put on the LCD. Once I've got that LCD, I make sure my coefficients are positive, and I change my divide sum into a times sum. Now, quite a few of you might be looking at this method and go, nah, sir, this all changing from times to divide, sir. No, I am not, this not for me. What I'm going to do is I'm going to show you an alternative. Now, I don't like this alternative method simply because it's much more, how can I put it, bull in a china shop kind of thing. There's no finesse to this. But let's have a look at it in any case, because I think for quite a few of you out there, you are going to actually enjoy the second method a bit more because it's a lot more understandable. So let's have a look at redoing this last example. So x over x plus 3 greater than 2. I am going to get rid of my LCD. And I'm going to multiply both sides by x plus 3. Exactly what I told you shouldn't do. But not just x plus 3. But actually I'm going to times both sides by x plus 3 squared. Now the reason I do that and the reason why I'm allowed to do that is simply because a square is always larger or equal to naught. So I know my inequality sign is not going to swap around. But I've still got to remember my restriction that x plus 3 may not be 0. Now if I follow through on this, that x plus 3 is going to cancel out with 1 at the top. I'm saying cancel out, I mean more, it's going to divide away, leaving me with this lovely expression, which I'm of course going to simplify. After multiplying that out, I'm still not done with my simplification. I need to get a 0 on one side. So in other words, x squared plus 9x plus 18, which leads me to x plus 6 and x plus 3. Ladies and gents, that's exactly what I got in the previous sum by changing the divide into a times. Oh my goodness! Maths is awesome. How we can do two completely different methods but get to exactly the same place. I love maths, guys. I love it, love it, love it. And this is why I'm a firm believer. You don't have to use my method. Find your own method to do. Find your own method that works for you. You know, if my method don't work and you like your teacher's method, please use it, or your tutor, please. I'm not going to feel bad if you tell me, nah, sir, I don't like your method. It's fine. My heart might be a bit hurt, but I'll get over it. I'm just joking. Let's finish off the sum. Negative 6 and negative 3. Draw my parabola. Get the part that doesn't apply, leaving me with that final set of solutions. Exactly what we got previously. Now at the top you'll see there, remember, x may not be negative 3 because it is a denominator in the original original sum given. So I'm going to have round brackets. For the last few minutes, I am going to mess with your mind even more. Now you might again go, no, please, no, sir, no, whoa. So I'm going to do a few weird questions with you. Now I love these questions because they're usually like 2 marks or 3 marks in the exam. And if you try to do it by using all of these, bull in a china shop method, you're going to sit here for ages. So let's start with a first weird question. Oh, let me not do all of that yet. X times by x squared plus 1 smaller or equal to 0. Now if I look at this sum, it kind of looks similar, same, but different. What is different is that in the brackets. But let's first of all look, when is something times by something else smaller or equal to 0? Either when it's a plus times a minus or a minus times by plus. Those are my only 2 options. But now I've got something interesting that happens because x squared plus 1 is always bigger than 0. Therefore, my first option of a plus times a minus is completely not possible because in the brackets is always a positive. This leads me to say that x must be smaller or equal to 0, meaning my first part of the expression, the x in front of the bracket, has to be a negative because a negative times by the positive in the brackets is smaller or equal to 0. So actually I've only got one set of solutions. X smaller or equal to 0. 2 marks, wham bam, thank you ma'am, we're done. Let's look at another example. X squared over x plus 1 is greater or equal to 0. 2 things that are a little bit different from this one. First of all, the x squared greater or equal to 0. That is something that is very good for us to know, but it's still a little bit different from previously. And you'll see later on in the question what I mean by that. And secondly, your denominator may not be 0. So in other words, x may not be equal to 1. No matter what we want to do the rest of the sum, x may not be equal to 1. So this means, ladies and gents, again, that top part is always a positive. So the bottom part has to also be a positive because, again, a positive divided by a positive, my answer needs to be a positive. So in other words, x minus 1 must be greater than 0. Now here's a difference. I don't include equal to 0 because x may not be equal to 1. That's a restriction. But now x is bigger than 1. Most of you would go, whoa, I'm done, sir. Party. Not done completely, ladies and gents, because there's a little bit of a big but. What about the numerator? Remember that the actual question was greater or equal to 0. Now, when is it equal to 0? Well, that is actually when x is 0, because then x squared is 0, meaning I've got 0 at the top, and equal to 0 is one of the possibilities. So therefore, my solution is twofold. First of all, x greater than 1, and secondly, x may not be 0. Oh, what an amazing video this was. It was so much fun for me to impart some of my knowledge to you. I know some of you are still reeling from this thing going, oh, sir, I still don't kind of get the times and divide becoming a times and that. But I encourage you, do not give up. Do not give up. Continue pushing through. Continue practicing. And if there's anything you're struggling with, ask a teacher, ask a tutor, ask a friend, ask me. Just make sure that you grasp these concepts. before I go, remember to hit subscribe, hit that bell for the notification to make sure that you get all the notifications. And last but not least, remember, on our Google Classroom, down below, there's going to be a URL that you can click to register yourself on our Google Classroom. Please make sure that you register. Please make sure that you get all of the worksheets with the memos. And have an amazing, wonderful rest of your day. This is Sarel van Grinnen, aka Mr. VG, signing out. Go and have a beautiful day. Cheers.